Chapter number 1, Database Systems. This chapter begins your journey of learning databases through multiple different applications. Learning objectives. We would like to really understand what's the difference between data, information, and knowledge. I'm going to throw knowledge in here. Talk about what is a database and why it's so important. It is one of the number one assets for any business. Let's talk about database design. We'll kind of talk about how databases evolve. I do talk a lot this semester about the history of databases. I think it's important to always know where we've come from before computers too. We'll talk about things that aren't so good, all the good components of a database system, and then these initials right here will be throughout the whole semester, our database management system. And another great way of thinking that is an ERP system, which I'll chat about in just a second. So why databases? Well, every single company has a database. I mean, you have to when people think about where you worked at and then all of a sudden you hit enter in the computer system or when you clocked in and clocked out, where did that information go? So the idea is to store the data and then we want to manage it and then ask it a question, retrieve it very quickly. So our class is about structured databases, meaning every data point that you're collecting has a spot where it's going to go. Kind of think of Excel. Think of a cell in Excel in a worksheet. Every cell is going to have something filled. Something has to go in there. All right, let's talk about Susan. All right, I always say that because I remember that movie. It was Monsters versus Aliens. It was that cartoon. I don't, you guys, when you were a kid, maybe you saw that one, but you had Susan. All right, let's talk about Susan. So in her average day, she leaves work, but before she leaves for work, or for like you leave for school, or you check in for school, you might have done a little shopping or check Facebook, Twitter, Snapchat, or whatever. Let's go a little TikTok maybe. Um, but if she enters something, have you ever thought about where is the likes stored, right? Where are those videos stored if you uploaded something? So during lunch, she stopped at like Walgreens and she grabbed her prescription on that. But think about like Walgreens. How did Walgreens know that Susan had a prescription? How did they know it was ready? How did they know when she picked it up and when she paid? Right? Where is all that data stored? Because Walgreens has this wonderful feature that you don't have to get out your credit card. They have this easy pay, where they have all your credit card information and they just say, want to place it on it? You say, sure, right? And truthfully, my Walgreens in my local town doesn't even ask for my ID. Kind of crazy on that one. After work, Susan goes to the grocery store. Okay, and then think about how did she pay and what did she pick up? And how does the grocery store know now that inventory value went down? At 9, she is planning a trip. So all those different websites that she goes to, and then all of a sudden now she has these ads that pop up. I'm sure you guys have seen that too. And then let's talk about that she made a couple online purchases at the end of the day. So each one of those companies, especially like Amazon, and Amazon will tell you, there's only 3 left, or purchase it by this time, or there might be a coupon to apply. How do they make that? Where does all that data get stored? All right, let's think about you. So during every single one of our theory lectures, I have these QR codes for you to feel like you're participating. I want you to participate. I want to, even though it's an online class, I want to hear your voice. And these are a great way where you can talk and it's on your time and on your schedule. So there's 2 different ways you can participate. Now remember, every theory chapter has 4 questions. Each question is worth 1 point. I hand grade these. I hand grade these. Okay, so all of a sudden you answer it and you're like, well, why do I not have any grades? I'm not that quick. I mean, I'm quick, but it's not instant, okay? Because I do have to go in and hand grade, and I hand grade after the due date for this participation. Now you can grab your camera, open up, or grab your phone, open the app for your camera. Don't take a picture, but just point it to the QR code and the Microsoft Form link will pop up. Or if you want to stay inside of your browser here or inside in PowerPoint, just pause me and then click on that question. All right, and that link will go right into Forms for you. So our little discussion here about Susan, let's think about you and what you've done today. So I'd like you to answer the question, what database or databases do you think you've already entered data into and you might not have really have thought about that? Okay, so please pause me and answer that question. All right. We're going to start at the very beginning. Data versus information. Data. What is data? So data is that raw fact, right? And a raw fact would be, if you think of Excel again, what's in that one cell. It doesn't mean anything yet. So if it was like a time clock and you punched in, it would just say 8 a.m. 8 a.m. doesn't mean anything yet, but if we process it, right, and we ask it a question, we could get a meaning through that, meaning that we could run a report and say that it is your employee ID and then pull every single day and see what time you punch in. All right, so now it becomes more of information, but then as we look at it, it becomes knowledge when all of a sudden we figure out that you always punch in early. Yay, good for you. And then we can see that you're a great employee. All right, so let's take a look here. Here's a data entry screen, which a lot of you guys probably have seen at your workplace. It could be your winter job, your summer, or if I have any non-traditional people out there, you're in some kind of system. Now, the system that runs the company is called an ERP, so Enterprise Resource Planning, okay? And then there's lots of different software that's out there. But as you enter things and you hit the checkbox or you hit confirm or you hit OK or enter, where does each one of these text boxes go? All right, so it goes into tables, and not just one table. Many tables are run in a company. The last company manufacturer I was in, I had 1,081 tables. Yeah, 1,081 tables ran the manufacturer. So when they hit OK, it had to go to some tables. Now from the table, then we can run a report. From a report, we can put it in a visual representation where this big pie really speaks out, right? Where as you just look at numbers, you're like, whatever. But when we see this, then the numbers are really talking to us. So a database, it is a integrated computer structure. It stores data. That's the biggest point of that. We have to grab the data when they hit enter and store it. Now, another fact behind the scenes is called metadata. Metadata is actually data about the data. And I know that sounds confusing, but I will talk about this all semester. And then even as we finish the semester, I will still linger back to a data dictionary. So a data dictionary is kind of like this image that I have over here on the right side. So it goes through your tables and tell you what are the field names. Now for you guys, you're probably still used to column names, but then it also tells us what is the data type, which we'll spend a lot of time on that, how many characters someone can enter, and then what kind of constraint and even a description and many other characteristics that the data can have. This helps us when we make reports. So we have all these tables where they're in a database, but you have to have this interface between the database and the end user, and that's what's called the database management system. So a lot of different software qualifies at this, And it's the idea of how do you get the data in, how do you store it, and how do you retrieve it. And it has tools in there so you don't have to do coding. All right, let's go back. Back is always good. So let's talk about the history of a database management system. Now, I like to relate to movies. Most of us, we've all seen movies, and so we do have some things in common. And you might have seen this one. It's called Hidden Figures. And what I liked about the movie is they were talking about the mainframe, and you saw all these big computers in the background. And then she talked about cards. And before we had fancy software to talk to a database, we had to use punch cards. And it goes back with the idea of yes, no, 1, 0. So it's a language that the computer understand, like off, on. And when something was punched, it knew it needed to do something. But thankfully, that was before my time. So 1960 is when the first database management system came in. And then we have this gentleman with his last name of Cod. Cod, and we'll talk a lot about him because he really was this beginning point that, wait a minute, there's got to be a better way to handle our databases. And he introduced this idea. Now, people built off of what COD began, and then they started defining what we call these enterprise or entity relationship models, ER models. We are going to make these in the next 3 chapters because it's so important to understand your design of your database and how, if you have 1081 tables, how do they talk to each other? And it goes on. In 1985, we have an object orientated because our data started getting more complex. Even today, with unstructured data, data that comes to us through videos and face recognition and through voice, comes back to this idea of the object. All right, then we can start going with Microsoft started with Microsoft Access, even though there was a different company before this one called Paradox. That one I did, believe it or not, I did work in that one. But we're going to start in our learning, and I'm going to teach you, and then we're going to apply it in Access. Then we're going to get to Chapter 2. We teach you, I talk you about database design more. Then we're going to apply it in Access. So our first 1/3 of the semester is all about learning and applying, learning and then applying, because Microsoft Access is still one of the easiest software out there to begin thinking about databases and then how your tables talk to each other. And the best part is I can take Microsoft Access and flip it in that same screen to show you the coding in SQL. Because after we get through our Access chapters, then the next third of our semester together is learning how to code without a database management system helping us. All right, and then things evolved even further when we start talking about then the internet and then maybe a little bit of tagging in here because again, the software, the data became so complex. Now, I just threw some more in here because there are a lot of database management systems out there. We do have MySQL. SQL has a lot of different dialects, meaning, like when you go to another country and there's slang, like I think it's Upper German and Lower German. And then when you go to England, some of the accents are like, woo, right? SQL has different accents too. Uh, Fox Pro, that old one is in there, but there's a SQLite, right? And then we have SQL Server. The coding we're going to learn in the next part of our after Access is more like SQL Server. It's like the basic, and I want to start with the basics before they put bells and whistles in. All right, advantages of your database management system, like your ERP system. So you can easily share data with everyone. We can have and view the data, but in user-friendly screens. Management now can get their reports a click of a button. Of course, sharing, security. We can take the database management system, put it in different modules. So payroll can get in here, but you don't want shipping to get in payroll. It can integrate then with other software like Microsoft Excel, and it just improves things so much more and makes the company more productive. I mean, the only other option here would be paper and pencil, and of course, back in the day, that was extremely difficult because no one communicated and the data was duplicated so much. Everybody had their own old-fashioned file cabinets. Now, I introduced these two words over here on the side because in Excel, Access, sorry, we need to know the difference. Well, in Excel too. So a filter. A filter is when we want a very quick answer to something, we don't save the result. Where a query is a saved question we ask to the database, so as the data gets updated, the question is still the same, but the output might be different because new records are answered. When we close the screen, this one's still here, filter is gone. Okay, I do like the images that come out of your textbook. You do have the option of using the ebook, which is in Cengage, or getting the loose leaf over at our library. You know, some students, you know, you still like that paper in front of you. So please do that if you like it. I like the way this screen looks because it's talking about the interaction. So here are the workers, right? And when they're sitting in their cubicles or their office, they do connect to the database management system. This makes the screens nice and pretty and easy. And then the database management system connects then to the database. Every single database is composed of many tables. Every table has the metadata behind it, so you understand how they were created. Just to give you another example, and then I put some titles in here, we have payroll, customer service, and sales manager, all working, and it could all be remote too. And when they look at their screens, they're looking at that database management system, the ERP system. Think again where you worked. What was that screen looking like when you logged into the company's system? And then the database management system then connects to that database. All right, types of different database. We have different types, and it really just depends on what you want to do. So we have a single user database, one user at a time. This would be more like Microsoft Excel because Excel now has a feature that you can create tables and then have the tables talk to each other through Power Query and then make a Power Pivot. But you can't have more than one person log in at the same time. A multi-user database would be Microsoft Access, because Access in one file, you can have 255 people logged in the same file at the same time, all working. Access really is a lovely program, even though I know it's old-fashioned. I know people are still getting away from it, but it's that our ERP system can't handle it. Excel can't handle it. What are we going to do? Access is that fix. And I used Access too for one of the companies when quality control had to print out stickers for their calibration on all their little tools. People had to be in there at the same time. It had to have a lot of different records, different tables. It was fabulous. All right, location. Now, sometimes it just kind of depends on where we want to put the database. It could be centralized, it could be different, it could be cloud-based. The database could be by the purpose of it. So it just depends again on what we want to do. Now, databases can be for analytical decisions on that one. It could be grabbing what we need out of the ERP system, saving it in another database, and then comparing it with all this unstructured data that we're going to get. A great example of unstructured, which I'll use again this semester, is the iPass. You know, in Illinois, you have a sensor in your car, and as you fly down the highway and you go through those toll booths, you don't have to throw quarters anymore. But think of everything it's capturing. And then you want to compare that to your structured data, right? So how many people are going through the tollway that's by us that could buy our location and how many products we have for offer on the shelf. I mean, any crazy thing you can come up with, but then that's not to do with our day-to-day sales, so we want to just have this database for predicting. Okay, and here too, I have this idea of this unstructured versus structured, which is our class. And you could have some that are semi-structured too. And a great example of that would be an email. You have the two, you have the subject, and then you have this huge area where you can put anything in. So semi-structured. We have databases that XML is using tags. Now, if any of you had me in ITSCM 285, which is the web design class, taggings, I call them, are the chompers. It's the greater than or less than signs, and you use these to tag certain areas, and then the database would understand where these tags are, so that way it can get some structure to it too. Types of databases, we do have Access, and then these are what the two that we're going to focus on for our class, so that way we can compare. One, Access kind of drags and drop. SQL, we have to code. I know. So I'm going to kind of start you. I don't want to code right away. I want you to really have a good understanding of your database before we begin in. Now, something new is when we're going to hit chapter 14 is what about, and now I'm going to change this, it's called not only SQL. So you use SQL plus you use other things because you have all this unstructured data. Why a database design is so important. You probably have heard the saying before, garbage in is garbage out, meaning if your structure of your database is horrific and it makes no sense, how in the world are you going to run a great report? So here's an example down below of just a bad table, because we have some blanks in here. Is it supposed to be blank? Is it not? Right? We could have a weird date in here because there might not be a constraint that you can't enter anything after the today's date. We have something here that says skill date 1, skill date 2, skill date 3, 4. What if they have a skill date 5? Or what if they don't have any skills? This is just a poor design because they're trying to cram everything into one table. Now, a good example of a design is taking that data and breaking it into 3 tables, because the 3 tables then give each table a sense of purpose. So we have a table named employee, certified, and skill, and the fields, for us column names still, but they're called fields, then organize it so it only collects what it has in common for that particular field, or we call them attributes when we get into database design. So certified has its own, employee has its own, right? Skill has its own. Now, as you're looking at these 3 tables, can you name like a question that you would like to see from these 3 tables? Okay. So how about give me all the employees that were hired before 2006 that have the skill of basic C+ programming. So I went from here to here, right? And then I pick and choose what fields I want, because these tables are going to end up talking to each other. Look at certified. You got employee ID, skill ID, skill ID. So since these tables can talk to each other, and we'll learn it's because we have a primary key to a foreign key, a primary key to a foreign key, and we're going to make a relationship, then we can pull any report that we want. All right, now I did one for you, but I want you to pause me. Name a report that you, as the boss, would like to see. Now it has to pull a field from more than one table, okay? So stop me, use the QR code, or use the link. All right, let's talk a little bit about history again. So the evolution of data processing first began with the good old paper and pencil method. They called it manual. It was horrible, but they didn't have anything else to do. So if you were in payroll, they had their own filing cabinets. Accounting, they had their own file cabinets. Shipping had their own file cabinets. And of course, all the data was duplicate, redundant, and somebody's file cabinet usually had mistakes in it. So from there, we went to this computerized filing system, which made life so much easier, but then we still had some issues too, that we still had quite a few tables and they weren't talking to each other. Now, don't get me wrong, I love Excel, and a lot of you guys know that I've named Excel Bob. Don't ask me, I know it's a goofy story. Excel is amazing, but every single worksheet is limited to 1 million rows. You can have as many worksheets you want in one workbook, but it's limited to your laptop or your computer's memory. So when you share files and somebody has not such a good laptop, the workbook will not work, right? So it's just not designed for users. So we had to have something else. So this is why database management systems evolved and the ERP systems evolved. Okay, so to understand our databases, we have to understand the basics. And the basics here, okay, so what is a data? A data, and I can use the word data value, is a raw fact. So if you have a field and it's for your employees, telephone number, birth date, or even in the customer table, the customer name, these would all be that one in Excel. Think of the cell, right? So a field. So a field is a group of characters that have a meaning. So all the telephone numbers together down that column, they have to have a title. The field name, the column name would be telephone number. All right, record. So record, think of the row, but it would be a cross for just that one person, place, or thing. So if I'm the employee, it would be Linda Ammon's phone number, Linda Ammon's birthday, Linda Ammon's address. And a file, I like to think as a table. So it's a collection of those records. Okay? Now you put all those tables together, and then you would have your database. So to keep those records from repeating, meaning we don't want someone to enter in the customer number a bunch of different times all over the place and then have to again put in their name. We have in our table, one of the fields is called the primary key. It's designated the primary key because it has to be unique. It has to have, well, I should say it can't be empty. So that way it cannot be repeated, okay? Unique, not empty, cannot be repeated. Now, in your tables, you could or you could not have a foreign key. So a foreign key is a field that was another field in another table that was a primary. So think back to where we just showed the other example. So it repeated in another table, but then it's not a primary key because it can then repeat it. It can then be null, but it's going to pull over from another table. What do you want to do? You want them, and I call it, you want your tables to then talk to each other. All right, so the whole idea of this is to help make sure that none of these happen. So we don't want lengthy times. We don't want them to run a report. It takes all day. We don't want people to enter in things in the wrong places. So we need some security. And we definitely don't want to have to code the whole time. Now I'm going to teach you SQL this semester. And the reason behind it is SQL is a powerhouse when things go bad. It can fix things like you wouldn't believe because it is the language of structure for databases. Now, extensive programming is an issue because when you have changes in there and it makes things more difficult and you only have the one person that understands it and then they leave you, now what? Right? It was only Jim Bob's, right, job. And now all of a sudden the company stops. So we don't want that. Structural dependence, too, is this idea that access to a file is dependent on its own structure, except, okay, it's modified to confine the changes will require 4 steps because the structure of your table is dependent on something else. Now, we have independence is when you can change the table, you can change the field, and you don't break it, meaning that you don't break the connection to another one. That is great freedom on that one. So in other words, we have 1081 tables. We want them to branch off to each other. We don't want this merry-go-round that every single table has to talk to every table. I mean, it would be a crisscross disaster with circles around, and that would be horrific. Now, that was with tables. Now you have data also, okay? So where you can change, and I guess I should say this is where you can change your data type, or you can change your the structure of it. So it's a good idea to make sure as you are thinking about the constraints that you enter on a certain field, you don't want it then to go and then limit the way you have to enter something in another table. So we have to think about the design. Data redundancy is this basic idea that you have, let's just say we have 4 different tables. Every single table, they have to enter the same bloody thing, right? So every table, they have to go in and type in that customer's address. Can you imagine how many mistakes that could be? So when you have data redundancy, instead of having the primary key to the foreign key, so pull in that customer address from the customer table, like when you want to ship something out, don't retype it. You can have all these horrible things that can happen. I mean, I'm a big one on this one, transposing digits. Um, like you see something, but in your head you flip-flop them, right? So why have them re-enter something when it can pull it? Anomalies. These are things that can happen to your database when, again, the structure and the design is not good. So let's say in this table that we have an agent name, okay, and the agent name, her last name, right in here, there she is again. Let's say she got married, and in the customer table, it pulls the agent's last name. So in her data is also held in an agent table, right? So we should just go in the agent table and then correct her last name in one spot, correct her phone number in one spot, and then have this table pull over the agent's number. So that way the agent number is going to talk to the agent table. But instead, what we have here is now a whole gobbledygook of mess because now what happens if we miss one or we forget to change her phone number? So this could cause a huge issue in our database. What we do want to go is we want to normalize, meaning we normalize our database to eliminate any kind of errors that we can have. We want to remove any redundancy. Now, a well-formed database should have the following characteristics. So if we go back and look at each table, so every table should be just a single subject. We don't want to have too many columns in a table if we could pull that out and make another table. Think of the Excel in the one cell should only have one value. That cell, that data value, shouldn't have a group of values. It should not hold first and last name. It should be a field for last. It should be a field for first, right? No data item will be unnecessarily stored in one or more table, because again, we would have redundancy, right? We want to make sure we have that primary key, and the primary key is designated so that way we do not have any empty records and we do not have anything that can be repeated. They all have to be unique. All right. And then we definitely make sure We are consistent, meaning we can lock down those fields so people can, users should enter only what they're allowed to. Okay, I want you to think about this one. All right, so please pause me. And here's the question. Which of the following would be the best plan to reduce data redundancy? So I want you to think about your data design for one table. These would be your field names. Which of these four is the best design for the fields? All right, database systems. Now, database systems is the idea that we do have a very good database, and then the system is talking about then the software that's going to pull from that database. You want to make sure that you select, right, a very good ERP system that you can create very good reports. People run reports constantly. They run these queries, the questions to your database. Like, you get in the morning and who didn't punch in, right? That was scheduled to work. What do we need to ship out? Do we have the parts that we need to ship out? The database management system, right here, again, is this software that's that interface between your database and your users. It really is the database system heart because the database software, besides just entering your data, has all these other features to it. All right, another little image for you to get this idea, right? There's our database. There's the system. Here's all the different people using the database at the same time, using that interface at the same time. And they're sharing the data. The data can come in from the employees, from all these different departments, from accounting, like when somebody paid their account or you ship something, so then you have accounts receivable, or you order something, right? Then where's that purchase order? Right? Was it received? And the whole idea is that instead of all those different filing cabinets located in different offices, now we can share the computerized data. I want to give you a couple examples that I use. This one was I worked in two manufacturers. So this is Vantage by Epicor. So here's the screen. Okay, and this one here is the purchase order. So you can see we have these lovely little text box in here where you type and tab and type and tab, right? It's dropping down, and when some of these are drop downs, it's going to pull from another table to populate so that way people don't have to type. You do have to enter in your quantity in here, but did you ever really think about when you hit enter, where does the data go, right? Where does the data go? Now this one's visual manufacturing. Now I use this at another manufacturer. So it's creating a part visually with these cards. I really did love this one because you have a screen like you're used to in Excel, but then you can also double click any of these cards to get into the screen to see more details. It also had a picture of the part, and then I could take the picture and put it on the packing slip so people in shipping can make sure they're pulling the correct part when they're shipping it out. The accounting system with visual was just lovely. And then here's visual again, but this was the customer order screen. So where you can type things in, again, where does the data go? Okay, when every time you edit things, are you editing in more than one table too? So every screen right here, I didn't have to code. I didn't have to put SQL. This is a user-friendly place where I'm interacting with my database, but again, I'm not writing any SQL code to that. I am just typing in. Once I hit enter, it goes into those tables. Another one which was visual pleasing, but none of the companies I worked for selected this one, but it's very popular. I just didn't like, in my humble opinion, I didn't like the accounting part of this. I had 13 different departments, and when we evaluated the software, I couldn't make my chart of accounts the way I wanted to. So I, I kind of influenced there a little bit and said, hold up. But this is a very lovely, easy to use, click a tile like an app and then you're in, but again, you're not looking at your tables. It's giving you visual pleasing screens to enter into your database. So the environment of your database is composed of these 5 components. So to run your database, we have hardware. Oh yeah. So how are you saving your database and where? So we have to worry about the servers, switches, which share the network, right? Routers, if we're going to connect to the internet on that one. The software, updates to the software, our ERP system, and then all the lovely utilities to keep it safe. People. Database system is definitely made of people because everybody needs to be trained. I mean, even the janitor will clock in and out in your ERP system, and they need to be trained on that. And I keep harping on training because it's all about your policies and procedures to make sure people are using the database properly. So hardware, software, people, procedures, and the most important is the data, those raw facts of data that's being collected. Another little visual picture for you to remind you how complex your database environment can be. And our database that we're designing is just one portion of that. Now that ERP system, the database management system, has a lot of different functions that it can do for you. One is definitely saving, meaning do we want to do a backup every night? Heck yeah. But the database management system, you can time it in there for you. It also then can have security, lock down different modules so people can't get in. We have the metadata, which I wanted to show you on the screen here with the database data dictionary. So your ERP system has a place where you can go in and you can look, like right here, look at this. I am looking at those fields and what is allowed for the data type. And there's more. There's the storage, right? And here I said again, the security. And some of them do give you permissions that you can lock down some of the screens. So yes, they have to get in that same module, but it's a view. And we're going to learn in SQL too how to create different views. I do like the idea that you don't have to use like another application then for your backup and recovery. You like in Microsoft Access, we have a place where we can click a button and it says backup and repair, and it will go through and it rethinks all the different connections and let you know if there's anything incorrect. Now your database interacts with your database management system, your ERP system, and then you also can use a programming language that you can manipulate your database, especially if there's some kind of issue, and that is called SQL. SQL is called Structured Query Language. We are going to cover 2 chapters, but we're going to take it slow because I know I have some of you that haven't coded before. So we take that in 4 weeks. Oh yeah, I go slow with it. We're going to do beginning query, and then we're going to do advanced SQL where we actually do create the tables, and then we will enter in records, but using SQL instead of Access. Now, databases is necessary. Every single company you can think of, from Amazon to Microsoft to let's talk about Harley Davidson or Miller Coors, right? Let's talk about beer. Why not? They all have a database. I mean, if we want to go a little bit local, let's talk about Generac. Let's talk about the UW system. There's databases there. So there are some things every company have to keep in mind about the cost. Uh, the ERP systems are expensive. Canvas, the right to use Canvas is expensive, but does the benefit outweigh the cost? They're complex. You always have updates to it. You are totally dependent on whoever created that software. Um, there's always upgrades. There's always training. behind the scenes, you might not know, but Canvas is always being updated. There's new features. Some features, depending on what campus you're on, are locked down. Some of them are open. And then when they open them up to Whitewater, we have training. Now, preparing for your career. Now, some of you guys might find this course extremely fascinating, and you didn't even realize that it's an option for you as a career path. The interesting thing about it is it's not just one career title. There's a lot of different job titles out there. Look at all these ones. We have the developer, the designer, administrator, analyst, architect, consultant. That's kind of more where I was at. Security. Don't forget, there's analytics in here too. So what I'd like you to do is let's become more aware. Let's see what's out there. So Indeed.com is where I'm going to go. And then I would like you to pause me. All right, use your phone's camera or click on my link right there. And for 1 point, I want you to go to Indeed, type on in that database developer, and let's go see what you find. I want you to name the position, what's the job title, the location, so if you found the state or even another country, and then what's the salary amount? And then take a look, please, at all of the job duties, because I know a lot of you guys are going to see SQL, so that should strike a little bit more interest for our class and us learning SQL. All right, this brings us to the end of our chapter. So for this chapter, we have the 4 questions for the QR as homework, so please, please make sure you do those. We also have a critical thinking review. I'd like you to do this review. It's in Canvas, which clicks over to Cengage. It just gets you going again on what is a field and what is a record before you start in the homework. Now, here's the kicker, okay? Pay attention to this. Do not copy and paste your answers from a Google search or from the PowerPoints for your homework. I know I have some definitions in there, but it's all about the semester. What do you think? How do you interpret it? I realize when it's a short question, a short answer, that part might match, but do try the semester, right? How do you, like in your own words, if you had to explain it to a family member, right? Or someone who has no database experience, how do you define things? All right, I'm really looking for that this semester. I want you guys to think beyond the good old copy and paste.